Welcome again. Our previous topic was counting sort. I was asked for an example how to implement the modified count to sort the array. Please remember that counting sort is based on keys between a specific range, and it is based on the frequency count of each element to be sorted and works as follows. We have input unsorted array A in range of 0 to k. N and k should be positive integers. For example, have the following input array. We create the count array, which is the frequency of the elements in the input array. As you see, 0 is not in the input array, so its count is 0. 1 is repeated 2 times, so its frequency is 2. 2 is repeated 1 time, so its frequency is 1. 3, 1, no 4, 0, no 5, 0. 6, 1, 7 is repeated 4 times, and 8 1 time. So the size of the count array should be k plus 1, where k is the largest element in the input array. And this is really one disadvantage of counting sort. In the previous lecture, I mentioned that there are two methods to implement the counting sort. One, from the count array, we can expand the count array by creating a new array the same size and as the input array and expanding the count. So 0 is not in the output array. 2 is repeated 2 times, 1 time, etc. But the complexity in this case will be in square, because we need one external loop and several loops for each count. Another method, which is better in terms of time complexity, is to modify the count array as follows. Here we 0, in this position the sum of the previous elements, 0 plus 2, here 2 plus 1, here 3 plus 1, 4 plus 0, 4 plus 0, 4 plus 1, 5, 4, as in Fibonacci series. This modified count array tells us where to locate each element from the input array and the output array. Now we have the input array and the modified count array. Here is the input array and the modified count array. Here is the modified count array. We create an output array of the same size as the input array to place the sorted elements in it. Now we start scanning the input array elements. The first element is 6. As you see, 6 is located on position 5. So we place 6 here on position 5 and reduce 5 to 4. Next we have from the input array 1. 1 is in position 2. So we place in position 2 1 and reduce the count from 2 to 1. Next we have 7. 7 is in position 9. We place 9 here, 7 here, sorry. We place 7 here and reduce the count to 8. Do you see, if we encounter 7 in the future, then it will be placed on position 8. This is the point. Next, we have 8. 8 is in position 10, so we place here 8 and reduce the count to 9. Next, we have 3. 3 is in position, as you see, 4. We place 3 in position 4 and reduce its count to 3. Next, we have 7. 7 now in position 8. So we place 7 here and reduce its count to 7. Next, 2. 2 is in position 3. We place 2 in position 3 here and we reduce its count to 2. Next, again, we have 7. 7 is in position 7, as you see. We place 7 here and we reduce its count to 6. Again, we have 7. It's in position 6. We place it in position 6 here and reduce its count to 5. Next, we have 1. 1 is in position 1. We place 1 here and reduce its count to 0. We are done since there are no more elements in the input array. As you see, we have here our sorted array since we scanned all the elements from the input array. This is how modified count works. Now it's very easy for you to follow the steps. We create a count array of size k plus 1. Then we compute the frequency of each element in the input array in the corresponding count. We update the count array. This is the modified count array by summing the current element with the previous sum, as in the Fibonacci series. Now the updated count array gives us the index of each element of array A in the sorted sequence. Next, we start to scan the input array elements and locate each element in the position indicated by the count, and after that we reduce the count by 1. After scanning all the elements from the input array, we can print the sorted array. Although I mentioned in the previous lecture about the complexity, as you see in this implementation, the time complexity is big O n plus k, and we need n plus k extra space as well. There are two major disadvantages of count sort. First, all elements should be positive. The second, if the array size n is small and k is high. Again, if we have, for example, 50 elements in the input array, but one of them is 10,000, then we have to create a count array of size 10,001. Thank you.